Okay, now we're going to get into page 22 of your workbook, looking at other bases besides the Mayan. In your book, it's a little bit different order. The Mayan comes more at the end, but we just dabbled in that shortly. So we're going to be going now from base 5 to put it into base 10. So we have to use a system in order to work with that. It's very similar to how we did the Mayan, not too much to worry about. We do need to know our breakdown of like how our exponents and our place values map out. So let's look at example 2.1. I'll do one with you and then you can do the rest for classwork and then check the answers. So here for 23, you would just count over. I would say, okay, that's the 0 and that's the power of 1. So I know I'm going to start with the power of 1. My number is 2. My base is 5 to the power of 1 plus my 3 times my base of 5 to the power of 0, and which I know is 1. But I'm just writing that for emphasis. So now here I would have 10 plus 3 equals 13, and that's in a base 10. You can write the word 10 or just put the number 10 as a subscript. Okay, so that's our example. I'm going to leave these two here for you to do for classwork. So if you pause the video and just get those done right now, I'll put the answers up. So here are the answers for the classwork problems, converting from base 5 to base 10. And it just makes sense that your answer, if it's a higher base, should be a smaller number. Now we're going to look at some more common bases that are used in computer programming. So we have the binary base 2. I'm just going to draw a little line through there to separate these out. Octal is base 8 and hexadecimal is base 16. So I will do the first one out and then you can try the others for classwork. So here base 2 again is just, again, you have the power of 0, 1, 2, 3, 4. So that's how I know where to start. So I know it's going to be something times 2 to the 4th, and then I'm going to look at my number here. So 1 times 2 to the 4th, and then just down the line, 1 times 2 to the 3rd, and then 0. Don't forget to just write that out. It's good practice. Times 2 squared, and then 1 times 2 to the 1st. And lastly, we have 1 times 2 to the 0, which I usually am writing a little 1 there so I don't forget and just inadvertently look at it. Funny. Then I have 16, and just calculate them out, plus 8 plus 0 plus 2 plus 1, and now I'm going to add up all those numbers, and I get 27 base 10 as my answer. So this again is our example. If you pause the video right now and work those other two right out while it's fresh, that's best. Okay, here's the answers to the classwork problems. So you can jot those down now or look at the key that I post under the videos later. I will do them out on the solution sheet. Okay, now we have converting from base 10 to other bases, and this is a little trickier because you just have to do some division and things. I'll show you how I do that in a calculator when we get to problems where it's kind of trickier, and there is a process that's outlined. really take a look at that page in your book on this whole process. But the idea here is we're grouping these. If we have 12 in base 10, how can we write that in base 5? So this one we can look at intuitively, and we can say, okay, well, I know I have 2 groups of 5 in there because we're looking at base 5. So if I said 2 groups of 5, that would give me the 10, right? And then there's 2 left over in my ones. Okay, so that would be the number in base 5, 2 base 5, or 22 base 5. Now, to be a little more systematic about it, when it's bigger numbers, different bases, it's a little trickier. What we want to do is say, okay, well, what is the biggest number of power of 5 that fits into here? So we have to think about what our powers of 5 are. And so if we have, I'll just do it off to the side. Start with like 5 to the 0, we know that's 1. If we have 5 to the 1, that's 5. If then we go to 5 squared, we know that's 25. So that is too big to fit into our number. So we can't use that. We're just going to start here. So that's where we start. And then we would take our number, 12, and we're going to just go ahead and divide in the 5. So we know 5 goes into 12 twice. Just do long division here. We have a remainder of 2. Now we're going to put the remainder up here. So this is where we get our 2 groups of 5. And then our remainder now becomes what we're dividing into. And the next power down is 5 to the 0 is 1. We do this all in our head, of course, but I'm just showing you the process. 2 goes in long division. Now we 0 out. So we keep going until we 0 out. And again, that's our 2. It's 5 to the 0 is our power here. Okay, remember, our power system looks like that. So using that idea and process just kind of intuitively, and then I'll show you a little more methodical. Your book also has a way to do it with the decimals and using just on a calculator, but I'll show you how to do just the long division on a calculator too, using calculator as a tool. But you're going to rewrite 35 as a number in base 8. So go ahead and start thinking about that. You're going to think about like what times 8 will fit into this 35. Like what power can I go, as high as? And then what times 1. Okay, so it's just 2 digits there for this one. Okay, so your answer for this one should be 43 base 5. And the thought process, again, is like how many groups of 8 fit into 35? Well, I could do 4 times 8. That would give me the 32. This is my check down here, not my answer. Just double checking, make sure it adds up. And then I have what times 1? Well, those leftovers there would be the 3 times 1. So my answer should be written as 43 base 5. Now here's a little chart for you to check out from converting from base 10 to base B, whatever that may be. And so we're going to follow this process and write it out a little more systematically with some larger numbers. And I'll walk you through that in the next section here. Okay, so the first thing I want to point out, this comes from a You Try It problem in your book. Those sometimes are fun to try. And by looking at the answer, I could tell that they have a typo in this workbook here. Maybe they wanted you to do out this big one, but I feel like it's a little long to start. So this really should have been written as a subscript. So it should be 657 base 10 is how we're going to do that, convert to a base 4 number. So go ahead and fix that. And then again, we have to think about what our powers are for base 4. So I'm going to jot that down over here. And I work kind of like right to left for these, just because that's the way I want to line it up. You could use a chart. Your book kind of just makes a chart that goes down. But I have 4 to the 0, of course, is 1. Then I have 4 to the 1 equals 4. 4 squared equals 16. So you're kind of noticing, okay, is that going to fit in? Yes, but I'll have lots of leftovers. And then 4 cubed would be 64. And then 4 to the 4th is 256. And then if we go one bigger, 4 to the 5th is going to be, I'll write that up here, is going to be 1024. There is a chart in your book for these, but you just use your calculator. Just start with, 4 squared and then times 4 to get the next one, times 4, and so on and so forth. So we can see here this number is way too big to fit into the 657. So we can't use that one. We're going to start here. So what we're going to do is take the 657, our number that we're working with that we want to convert, and we're going to divide this power, 4 to the 4th, into it. See how many powers or groups of 4 to the 4th are in that. So we can lay this out. It's going to look like this. Remember, what times 4 to the 4th will be that first value. So if you just do it on your calculator here, you can see here 657 divided by 256. I mean, you could do these just out the long way too in your head if you want. And then I get a 2. Well, this has decimals. It's not going to be a remainder of 5. Be careful of that. So just clear that out and now do 2 times 256, or you can just do that in your head. And I'm going to get 512. So I go ahead and write that here, just long division. I'm going to figure out what my remainder is, and you can just figure out that the long way around, or you can just use your calculator, that's fine. But I have 2 groups of 4 to the 4th. And I'm going to work systematically that same way. So now I take this 145, that remainder is going to tell me how many groups of 4 cubed, the next thing down. So I have to put 64 into the 145. I'm trying to think of how many groups of 64 do I have in that 145 to know what this value should be for my answer in base 4. So again, I'm just going to go ahead and divide it out, and I would get 2 groups right here. And the 2 times 64, probably just do that one in your head too, but subtract the 128, and I get 17 as my remainder. So I know this needs to go here. So my next grouping, I'm going to take that remainder and put it up here. And my next one down, this is why we always want to write these out too. 4 squared, that's how many groups of 16. So I'm going to divide 16 in there, and obviously I get 1 with a remainder of 1. I put my 1 there. So make sure you're putting these where they go, match up to the powers, or make a table or a chart or something to track your work. So the next power that I have is actually 4. So what times 4 will ever give me 1? Well, nothing. So it's a little too big, so I'm going to put 0 there. That's just a spaceholder for that one. And then lastly, to get 1, I would obviously just have the 1 at the end. Okay, so I've just followed out the pattern the same way I was doing before. Take the power of 4 to the first, I put it into 1. I can't get anything more than 0, so go ahead and get my remainder, put that up here. How many sets of 4 to the 0, which is 1, divide into that until I zero out and I'm done. So now to write the answer, I would have a 2, a 2, a 1, just following along here, and a 1. And so that would be my answer in base 4. Now go ahead and try this 4,509, that's in base 10, to convert to a base 7 number. So that's going to be your classwork. And go ahead and try that one. And then check your answer. Okay, so there is an example for this one with steps in the book, but try it yourself first. But if you get stuck, you could look at page 55 for that. The answer is right here. I'm leaving space because I will write out the solution the way I did it in the examples. Okay, we're actually not going to do the arithmetic too much more with this. So we'll skip these addition and subtraction with other bases. I think you get the idea. I wanted you to just get a feel for working with those, especially if you're thinking about computer programming or using other types of things. There is the example on page 56 to 60 on how to use a different method when you're converting. So you might want to check through that, but we're just doing this kind of for fun. So you can skip this section. It's getting kind of long. All right, thank you for watching.